Okay, to get the parameters needed for an unknown transformer, the best way to do it is you're going to have to build yourself a resistive box. You have a bunch of high power, high wattage resistors laying around, or you can just set something up with incandescent light bulbs, 120 volt, if you can still find these. So basically, all we need to do is make like a channel. I mean, this is just made out of just wood. Screw it down. And then here's our dimmer. Okay, make sure that it says up. And then you have your on-off switch. And we'll put some of these here. These will be our loads. So what do you got in your basket? Hey, wiring up the backside. I added these just in case I want to add extra onto it. So there's the finished. These here, that's in case I want to expand onto it, like add another one of these. I doubt if I ever will. Everything's right, set, ready to go. So another thing you're going to need to make is what we always call the suicide cord. Basically, it's a cord, 2-prong, and then you just put an inline switch off and on, and then a couple alligator clips. You can see why we call it a suicide cord. Now, make sure you wire this properly, ohm it out, make sure it's not crossed, test it, and then when you're done, put this bad boy away so that nobody's going to find it. I mean, I closed the door to this room, but it also goes outside, so I can't lock it up. But just make sure nobody gets a hold of it, like little kids or anything like that. Okay? All right. But you need to make one of these suicide cords to finish this off. Okay, so then we're going to be testing out this transformer. We got our setup here. It's off all the way. I got a couple 100-watt bulbs. Okay, I can take them in all as I want. Here's my whatever. I got this here set up for voltage, and then I've got that set up for current. So we recall as for a full wave power supply, if you vector it, voltage max times time, you got four pulses per 2 cycles. And this is peak, not RMS. And then you have a ripple voltage, and that's going to be in peak to peak. VDC is going to be right in between. So you got 10 at the lowest, 15 is your voltage peak. So your VDC is going to be 12.5 volts. Now, you got charge rate, discharge rate. Charge rates are always the same. Discharge rate is going to, it depends upon your capacitor, what that charge rate is. Now, as your load increases, your ripple voltage is going to increase. Your voltage max will always be, the 15 volts per cycle is down to 8. Now VDC is going to go down to 11.5. Okay. So as load increases, your ripple voltage is going to increase also. So you design your power supplies with a light load, and it's defined as a ripple factor of 6.5% or less. VDC is within 10% of voltage max or voltage peak, not RMS, not what you're going to see on your meter. Okay, that's different. So let's go ahead with that. Let's go ahead and turn this bad boy on. And we've got 20.8 volts. These are off. Turn this on. And if I'm moving this all the way, it shouldn't change because these are not screwed in. So I'm going to screw in one at a time. I'm going to watch my voltage as I'm turning this here dimmer switch 20 points. I'm not, and that's right now. What do we got here? About 0.3 amps. If no load is going to be 20.7, I need 18.7. So let's go ahead and screw the other one in. These are 100-watt lamps. All right. Again, we'll turn that down. 20.2, 0.6. Yeah, I'm still not. I mean, I get a little glow. That's about it. So I need to add more. To this. So let's go ahead and turn this down. Shut this off. Okay, so I added a 10 ohm resistor. Go ahead and unscrew these. Bring that back on. 20.9. I got nothing. So this all the way down. So let's turn it on. All right, so now let's go ahead and adjust our dimmer. Let's see what we get here. So I wanted what, 18 point something. Now I'm getting is 19, 1.5 amps. So let's screw in one of these guys. .7. Well, I should turn this down a little bit. And we'll screw in the other one. Okay, so I want 18 point something. Now I can get down to 19 at 2 amps. AC, 19. Doesn't feel warm. That's feeling warm. Okay, so I'm not getting down to the 18, but I'm getting 2 amps out of that thing. Now, I'm going to shut it off and show you. It's an old Archer, and it's rated 18 volts, 2 amp. Well, I was getting 19 at 2 amp. So basically, the setup's working. Let's try something else. Okay, let's look in our drawer of stuff. This one marked. That one's not marked. Let's test this one. Okay, I got that one wired up, off. These are loose. I disconnected this. We can always hook that back up. So let's go ahead. We got 29.65. All right. So what we want then, we're going to want 27.6. All right. One in. This is all the way down. Turn that on. Okay, hang on. Okay, we're getting there. Let's try this again here. That was pretty quick. So 29.7, I need 27.7. We just have one screwed in. 27.7. A little bit at a time. We're just moving this here dimmer just a little bit at a time. So there, 27.7, that's 10%. And I'm getting 0.13 amps. That is a light load. Shut it off. All right. So that's why I can mark this one then at 29.7, 0.13 amps. Okay, so the last one transformer I did, I actually got that wrong. I should have went down to 26.6 volts. That would have been 10%. Oh, my bad. But you get the picture. You need to know what the current carrying capabilities of the transformer is on a light load. All right. From there, you have the data then to build your power supply. Or, these transformers here can also be used, especially if you have a center tap, push-pull amplifier for audio. Is, you get the picture.